Okay, lesson 3, altitude and right bisector. So these are two more types of lines that can relate vertices and sides of a triangle, just like median from yesterday. So the first one we're going to look at is altitude. And the altitude is just another name for height. So it's the line that goes from the vertex of a triangle to the opposite side, and it has to meet the opposite side of the triangle at 90 degrees. So it starts at this vertex here, it would meet at 90 degrees. Okay, so this line here is your altitude. Okay, if we want to find the equation for the altitude, we have to do a couple of things. First thing we have to do is we have to find the slope of the side the altitude is going through. So for example, in this triangle, ABC, okay, we would have to find the slope of BC first. Once we know the slope of BC, we can find the negative reciprocal, which tells us the slope of the altitude, which is this line here. Okay, once we know the slope of the altitude, we can use the slope from the altitude and substitute it into the equation of the line and find B. Okay, and then last step, we're going to write the equation and we'll have all of our information. Okay, so it's similar to finding the median, but instead of using midpoint, we have to use the slope of BC and then use that to find the equation of the median. The second word that we're going to learn today is called the right bisector. Okay, so the right bisector is a line that meets another line at a midpoint at 90 degrees. Okay, so if I have my triangle down here, triangle ABC, my altitude would pass through the midpoint of BC and go straight up at 90 degrees. Okay, so it would pass through midpoint and make a 90-degree angle. So you can see in this triangle it does not go through A, which is fine. Okay, it would only pass through A in equilateral or isosceles triangles. Okay, so if I want to find the equation of the right bisector, the first thing you have to do is find the midpoint of BC. Okay, once you find the midpoint, you can find the slope of BC and then use that slope to find the slope of the bisector because they're perpendicular. The last thing you want to do is substitute in the midpoint and the slope and find B and then write the equation. Okay, so these are all different steps you have to take. You just have to remember what you're looking for and what line you're doing. So if you're using altitude or right bisector, you're using 90 degrees, so you have to use the perpendicular slope. We're just going to go through one example where we find the right bisector and the altitude for one triangle. Okay, so here's my triangle, ABC. The first thing we have to do is draw a diagram. So point A is 4, -6. Okay, point B is 6 and 8. And point C is -3, 2. So I've got my triangle. And for part A, what we're going to do is we're going to find the equation of the altitude. Okay, and then part B, we're going to find the equation of one of the right bisectors. So for part A, we can draw it onto the graph, use blue. Okay, we have to find the altitude from B to AC. So what that means is the line from B has to hit AC at 90 degrees because it's the altitude. Okay, so here's my altitude. Usually what we should do is we'll label it. So our altitude is B, and we can call this D. Okay, we don't know exactly where it's crossing. Right now I'm just estimating from the graph. Okay, so we're going to use the 4 steps from the note to find the equation of the altitude from B to AC. First thing we have to do is find the slope of AC, and then we can use that slope to find the perpendicular slope, which will be our slope of BD. So slope of AC, we use our slope formula. So we do y2 minus y1. So we're going to do 2 minus -6 because we're using A and C. Okay, so A and C. And then x2 minus x1. So -3 minus 4. So our slope is 8 over negative 7. Okay, which means our perpendicular slope is the negative reciprocal of that. So the way we can write this to keep it nice and organized is the slope of AC is 8 over negative 7, and the better way to write that is negative 8 over 7. Okay, so our negative sign is on top of the fraction. So that means the slope of the perpendicular line, which is going to be BD, is going to be positive 7 over 8. Okay, so you flip it and change the sign. So the slope of our altitude is 7 over 8. Once we know the slope of our altitude, and we know a point, we know point B, we can use the point and the slope to find our equation. Okay, so what we're going to do is we're going to find B using the point and the slope. Okay, so I'm going to substitute in 6 and 8 for x and y, and I'm going to substitute in 7 over 8 for the slope, and we're going to find B. Okay, we're going to move this to the other side, and we need to have common denominators. So I'm just going to make it 64 over 8 minus 42 over 8 equals B. Okay, and once you subtract, you should reduce your fraction as much as you can. So our fraction is 22 over 8 which means we're going to divide by 2, so our value for our y-intercept is 11 over 4. Okay, so when we write our equation for BD, this is for our altitude, okay, we'll have y equals, and our slope is 7 over 8, and our y-intercept is 11 over 4. Okay, so finding the equation for the altitude is pretty quick. You just have to find the slope, find the negative reciprocal, substitute it into y equals mx plus b, and write your equation. Okay, now we have to do part B. So I have my triangle here, so we're going to do part B, which is find the equation of the right bisector of BC. So if you look on your triangle here, BC is this line, so our right bisector is going to go through the midpoint of BC and hit it at a 90-degree angle. Okay, so we know that this point here is M, which is our midpoint, and we know that it's 90 degrees. Okay, so to find our right bisector, the equation of our right bisector, we have to find the midpoint of BC and the slope of BC. And then we can use those two things to find the equation of the right bisector. Okay, so first thing we're going to do is find the midpoint of BC. So we use the midpoint formula from yesterday and the day before. Okay, so we have x2 plus x1 divided by 2. Okay, so I have my 6 plus negative 3 divided by 2. And in the y section, we have 8 plus 2 divided by 2. So the midpoint of BC is 6 plus negative 3 divided by 2. So we have 3 over 2 and 5. Okay, so now that we know the midpoint of BC, we can find the slope of BC. So the slope of BC, we use the same 2 points. We're still going to use 6, 8, and negative 3, 2. Okay, we fill them into the slope formula. So y2 minus y1 divided by x2 minus x1 equals negative 6 over negative 9. And we reduce that, so it's our best possible fraction, so our slope is 2 over 3. Okay, so this is the slope of BC. What we want to do now, because we're doing the right bisector, is we have to find the slope that's perpendicular to BC. Okay, and we know that that's the negative reciprocal, so we flip it. and we change the sign. So the slope of our perpendicular, or our right bisector, is negative 3 over 2. Okay, so I can use my midpoint, and I can use my slope, and I can find the equation of the right bisector. So what we're going to do is just substitute in 3 over 2, 5 for x and y, and negative 3 over 2 for the slope, and figure out our equation. So we have 3 over 2, 5, and negative 3 over 2 as the slope. So when I fill everything into the equation, okay, I just need to rearrange and solve for b. So 5 equals negative 9 over 4. Okay, I'm going to move this to the other side, and I want to make common denominator, so it's going to have 20 over 4 plus 9 over 4. So we're going to have 29 over 4 as our y-intercept. Okay, so when I write my equation for my right bisector, so this is for the right bisector coming from BC, I'm going to fill it in, so I have my slope is 3 over 2, and my y-intercept is 29 over 4. Okay, so finding the equation of a right bisector means you have to find the midpoint, and then the slope, flip the slope so it's negative reciprocal, and then find the equation.